First of all, we are senior aerospace engineering students, and we would like to thank our department and especially Dr. Pinto to have this organization for us. Our topic is end-to-end software modeling and simulation of solar sail propelled CubeSat class spacecraft targeting asteroids and minor moons. And you may start, Aytürk.
Thank you. Good afternoon. We would like to start our presentation with the explaining purpose and the motivation of our study. Our aim is to create a modeling environment by using the available free open source software, which can achieve to simulate the solar sail propelled CubeSat mission with its all subsystems and the possible failures that might happen before, during, or after the mission. The main motivation of us is the lack of such simulation environment that can achieve to simulate mission from beginning to its final state. Next. Here is our presentation plan. After a brief literature review, we will proceed with the pieces of software which we used. Next. According to the literature review conducted, the solar sailing, which is the term used for the solar radiation pressure of the sun as the propulsion source, is not a hypothetical idea, but it was tried by several well-known space-related institutions such as NASA, the Planetary Society, and JAXA. Next. Here you see the picture of Cosmos 1 from the Planetary Society. The mission failed due to a launch vehicle failure and it could not reach the orbit. Next. Then we have Icarus from Japan Aerospace Exploration Agency, and it was the first successful interplanetary mission with the solar sailing technology. Next. Then we have LightSail 1 mission. It was also a failure due to a launch vehicle failure, and it was the second attempt of the Planetary Society after Cosmos 1. Next. Then we have LightSail 2. It was a successful technology demonstration of the solar sailing technology, and the spacecraft is still in orbit. Next. And then finally, we have the Near-Earth Asteroid Scout, and it will be the first CubeSat mission to asteroids, and it will be launched in 2022. And it is planned to use the solar sails of the spacecraft for navigating purposes while approaching the asteroids. Since the solar sailing is a newly developed area, it would be great to have a test platform such as the one we are trying to build. And next, Burak.
Now I will talk about the FreeCAD. FreeCAD is a FOSS program using for the design the 3D models. In this project, we design our own model and use this model to visualize the other FOSS program related with our project. And we use the two phases to create our own model, which is the one of the is part design and other is assemble. In part design, we individually design all related parts of the spacecraft. As we can see in the sham, these are the structure part, CubeSat frame, solar panel, and solar sails. In those parts, CubeSat design is a 6U for the model to be realistically balanced with the mass related with other parts. And for CubeSat frame, for the solar sails and the CubeSat structural parts, we use the octagon shape to increase our solar sail area and collect more solar radiation pressure, which we increase our area to 3,200 meters square for this purpose. And also we design deployable camera for the collect data from the deep space and solar panels for the electrical power. Next. As it's in the table, we have the length of the booms, which are basically the sail mast, and total length of the booms are the 32 meters to increase the solar sail area. Next. Now we can see our second phase, which is the assemble. We assemble all related parts to obtain one body, and we can see how our related parts interact with each other. Next. Also, we can see our solar sail is deployed with CubeSat. And as I mentioned before, FreeCAD, we use the FreeCAD to make our own model and to visualize the other related FOSS program. And we create an animation for how our sails are deployed in Blender. Next, Öykü.
I'm going to explain what is Blender and how did we use it. Blender is a three-dimensional modeling and animation application. This application was used more in the cinema industry. However, over time, it has been used in other fields as well. NASA uses this application in many different areas. For example, interactive web application of Mars exploration rovers was made with Blender. We worked on Blender and learned its features. Then we simulated our CAD model. You see a simulation on the screen right now. We followed certain steps to create this. We imported the spacecraft, which was made with FreeCAD, to Blender. We changed the background color to black and added stars and the sun to create a space environment. Then we focused on the model. The panels, the booms, and the sail were simulated according to deploy in order. To get a realistic view, we added a metallic texture to the outside of the spacecraft and a reflective texture to the sail. After these steps, we rendering. In order to make the movements understandable, we created several different views by changing the perspectives. Finally, we obtained this video by rendering. So this is the whole process. Next, Aytürk.
I will briefly explain the NOS3 and its working principle. NOS3 is a software simulation testbed for small spacecraft, and it was developed by NASA for STF-1 simulation to flight 1 mission to simulate the spacecraft subsystems. The main advantage which NOS3 brings is the fact that it can connect Cosmos and 42 in a single platform. Thus, we are planning to utilize the benefits of NOS3 by the means of implementing our spacecraft and the mission details into it. Next, Mehmet.
I will talk about 42, which is a simulation tool and flight software for attitude determination, orbital dynamics, and control. Its features are multiple spacecraft can be used in the simulation. Also, celestial bodies in the solar system are added into the program, including minor bodies like comets and asteroids. Also, it's an open source tool, so it's available on SourceForge and GitHub. And finally, it can be run on Mac, Windows, and Linux. As you can see, there is a default mission on NOS3, which is a Linux-based program operating system. And when we try to edit this parameters in here, we have three main files. So these are input simulation, orbit layer, and spacecraft NOS3. For input simulation, we can change the environmental decisions at there. And for orbit layout, which is the orbit low Earth orbit, we can change orbital parameters in this file. And finally, for the spacecraft NOS3, to edit spacecraft parameters, we should edit this file. And after that, you can see the 42 on Windows. It is way faster than NOS on Linux. And this is our unique spacecraft model, CAD model, and you can see the sun at the background. So we have some possible feature missions. The first of all is to design a trajectory from to Earth to Sun by using the data folders provided by 42. And we want to improve our CAD model by adding solar radiation pressure on the specific points of the spacecraft to observe the trajectory change in time. And finally, we want to design a trajectory from Sun to minor moons by using the solar radiation pressure as a thrust. Next, Uygar.
I will give information about the Cosmos. Cosmos is the open source command and control software package. It was merged into the NOS3 to provide end-to-end testing STF-1. Cosmos provides a command satellite and analyze the telemetry settings. And also it can be only launched in NOS3 in Linux. As you see in the figure on the right, Cosmos contains some specific section for investigate the spacecraft, which are commanding and scripting and the telemetry part. Basically, command and scripting parts allows the graphical connections, shows the execution sequence with using command sender and command sequence, and also it runs the test scripts, gives a general organized framework level testing, and turns command package logs into the text file. And the telemetry part gives us real-time representation, allows a method for getting unique screens, graphs, and creates data in real time with using telemetry grapher and packet viewer. And also it can convert telemetry packet logs files to SVS data. And next, Burak.
Now I will talk about the GMAT. GMAT is a software developed by NASA for simulating how spacecraft behave in trajectories when they are in the space mission. Today, many companies and administrations, such as NASA, Boeing, or Raytheon, use the GMAT in their mission. In this project, GMAT considered for which problem or failures we can face. And we have one major problem, which is our spacecraft re-entering the orbit. When we see in the figure, we see our model is follow the elliptical trajectory. And this trajectory related with the interaction of the sun and our model and the using time of the solar sphere solar radiation pressure. In the figure, green trajectories are showed when thrust on, which means we use the solar radiation pressure, and how perihelion increases, and the red trajectories is where the thrust is off and perihelion decreases. Next. In this figure, we can see our major problem, which is our spacecraft is start re-entering to orbit. And next. As we can see the simulation results, our periapsis is decreasing, which the time and the semi-major apsis and apoapsis increasing, which apoapsis increasing gives a hope that this mission has a future for the success, but we must consider how we can solve the problem. And in the future of this project, we will consider how can we solve this periapsis decreasing, and we will consider how we reach the deep space, collect data from minor moons and asteroids. Next, Hazal.
I am going to talk about OpenMCT. OpenMCT is a free and open source software and web-based framework that stands for Mission Control Technologies. The aim of OpenMCT is to analyze data from spacecraft missions. OpenMCT features client software running on a web browser. Markov, LightSail2, and Asteroid missions are missions that use OpenMCT to provide visualization of telemetry data and carry out analysis of results. The user can create their own objects by pressing the Create button in the top left corner of the screen. Another way for the user to create their own objects is to write their own code. In order to create objects by writing code, it is necessary to know JavaScript. Object trees for specific purposes are created from these created objects. Figure 16 is flexible layout object. The first plot in the flexible layout object tree is the sine wave generator. The second plot is the state generator. These two plots were created with the help of the Create button. We placed the telemetry table at the end of the flexible layout object tree. Telemetry table is one of the most used features in OpenMCT. Next. The figure 17 is map object. One of our main goals in our project is to be realistic. For this purpose, we choose map from the options that appeared by pressing the Create button in OpenMCT. We can export the objects we created in OpenMCT as JSON file. In addition, we can import the JSON files we created by writing code to the object tree. Next, Mehmet.
So I will talk about our Gantt chart, and we set some goals to achieve in the previous semester, and we achieved some of them. And as you can see from our Gantt chart, we have some future goals, and we will try our best to achieve them. And this is our conclusion section. And for FreeCAD, we create a unique CAD model. In the further steps, we want to add the subsystems into our model and get better results in the piece of software that we use. For Blender, we imported our CAD model into Blender and simulated the panels, booms, and sail to see the movement that we applied. In the future, we want to make it more realistic and show the whole process in the solar sail model. For NOS3, we used NOS3 in the Linux, as it was discussed. Now we want to use our spacecraft in NOS3 and model the subsystems. For 42, actually we run the program on different operating systems as Linux and Windows, and we got some results. And now our aim is to communicate with Cosmos and simulate the whole mission in 42 for Cosmos. For now, Cosmos can only be used on NOS3, which is a Linux-based operating system. Thus, in the further steps, we want to use the telecommunication system provided by Cosmos on our model. For GMAT, we used solar radiation pressure as a propulsion system. In the mission, we obtained a re-entering to the atmosphere. Thus, we will investigate the problem better and improve the simulation. And finally, for OpenMCT, we analyzed the mission control system and researched about that, how we use it. And for the next steps, we will track our data, make them visual, and monitor our mission by using OpenMCT. And this is our reference section. Thank you for your attention.
All right. Well, Eric, I can only smile thinking what you are saying, what you are maybe thinking when the students are presenting 42 to you. So I don't know how they are feeling about it anyway. For those of you who are not aware, in this workshop, we're going to have the developers of most of the programs that this group has been using and others. So it is a very special privilege to be able to present this to the developers, although of course there is a lot of pressure on the students to explain to the developers what they understand of what was developed. So thank you again for this effort for Group 2.